All right, in this video, I'd like to go over the practice 3, well, for this semester, the practice 3 assignment, which is called composition of functions. So it's kind of like what we were doing before, where we were doing f plus g of x or f minus g of x, where we had operations on functions. Compositions are like that, but a little bit different. So let me present my screen, and hopefully I can explain this to you with my drawings. Okay, so hopefully you see a screen that I'm writing on. Okay, a composition of functions is a little bit different. Here's how you write it. Let's say f of x represents x plus 1, and g of x represents x plus 3. We'll just keep it simple. Okay, so I probably should have color-coded those, but whatever. Okay, a composition of functions is when you feed one function. So remember, a function is if I feed in, let's say, the number 3 into f, f will output 3 plus 1, 4. So in, out. Whereas g, if I input 3, it will output 3 plus 3 is 6. So functions are a mapping of inputs to outputs. They're one-to-one. And these two functions are different mappings. So if I put a 3 into each of them, they each give me a slightly different output. So they're different functions. A composition is when the output of one function is the input to the next one. So let's say I have, let's say I want g of f of, well, I'll say 3. So what does that mean? Well, it means I first have to put 3 into f and figure out what that gives me. I'll sort of come here. And then the output of f becomes the input of g. So whatever pops out of f gets fed into g, and then g pops out whatever it's going to pop out. So if I plug 3 into f, 3 into f gives me 3 plus 1, 4. And then that 4 is fed into g. So what does that give me? Well, if I plug a 4 into g, that's 4 plus 3, 7 comes out. So this would be 7. And that we call a composition. You first do the inner one, just like you were working with parentheses. Work on the innermost set. Plug 3 into f, you get 4. And then that is, once you resolve that inside, you're left with just the number 4. Then you have g of 4, and then you resolve that, and you get 7. 4 plus 3 is 7. That's called a composition. So you can write a composition like this, g of f of x. That's one way to write a composition. The other way to write a composition is using this little open circle. So you could say g of, I didn't do that well, of f of x. Those mean the same thing. It looks like goth. But this means composition. This means first feed it into f, get the output of that, and then feed that output as the input into g. So first f, then g. So this is the way of writing what's called a composition. So we just did that with a specific input 3. Now, if you weren't going to have a specific input, if you're left with a variable x, you just take g, so g of x, right? Well, it's not g of x anymore, it's g of f. So I'm not going to say x plus 3. I'm going to say f plus 3. Well, what's f? F is x plus 1. So the composition is when you take f and you plug that into the x of g. So instead of x, it becomes x plus 1. And then, so the composition would become x plus 4. So f adds 1, g adds 3, the composition adds 4. So that's all that you have there. And you can see if I did that composition and then I plugged in, well, what's g of f? I'm sorry, at 3, we already did that. We did that, it was 7. But if you did this as an expression, you do 3 plus 4 and you get 7. So it works out the same. You can do that with a graph and with a table. So let's say here's f again. And we'll say, right, this graph sucks, but let's just say it's, let's say at 2, it's at 1.5, or somewhere around there. And let's say at g, it's just a constant function, or let's say it's whatever, you get the idea. Let's say it is at 2 goes to 0, 2 steps, so it's at 1. Well, yeah, whatever. So that means it's at a half, at 1.5. Okay, so if we said, what is g of f, oops, of 2? Well, what is that? That is, well, f at 2 is 1.5. That becomes g of 1.5. And then what is g at 1.5? It's a half. So this would equal 1/2 or 0.5. So that's how you could do a composition with graphs. Take the input, figure out what the output for that input is on f, and then use that output as the new input for g and figure out what that output is. Again, that's called a composition. I could have written it like g of f of 2, and it would have represented the same thing. You can also do that with tables. I'm not going to do 5. So let's say it's -2, -1, 0, 1, 2. And then let's say it's 6, 3, 0. What am I doing? -3, -6. All right, so you got 2 functions. We might say, what is g of f of, let's say, 4? Okay, well, again, that is, what is g of f of 4? Those are the same thing. Well, f at 4 is 2. So this becomes g of 2. And then since f gave me the output of 2, that 2 is going to be the new input of g, which outputs 0 at 2. So that would give me 0. I could also say, so I mean, my steps were on that one. Start at 4, go to 2, and go to 2, and figure out what the output is there. That's how that one worked. I could also ask, what is f of g of, let's see what a good one would be, 1. So now g gets fed first. That's f of g of 1. So g of 1 is, I'll do a different color. G of 1, start here, gives me 3. And then 3 as the new input would give me, for f, 1. So I should see that g of 1 is 3. And then f of 3 is 1. So that's how compositions work. You just feed one into the other that way. Yeah. Now you could do something kind of funky, which is like, what is f of x, where you feed the function back in on itself kind of repeatedly. So f of, let's say, 2. So, well, what's f of 2? F of 2 is 0. Okay, so f of 2 makes 0. Well, what is f of 0? Well, that's minus 2. So you can keep, 2 goes to 0, 0 goes to negative 2. You could do that way. So you could even use the same function. So don't be confused by that. All right, that's composition of functions. I hope that made sense to you. It's just a different sort of notation, but I hope the concepts are clear. I don't think they're super tricky, but you do got to sort of understand what the notation means in terms of the concepts. So keeping that clear might be tricky, but I don't think the concepts are too bad. But you have practice, so I hope all that helps. You guys have a great day.